Good morning, everyone. I'm not a morning person, so probably I will speak a bit slowly. Today, the intention is pretty much share, so I'm not here to teach you guys anything. So we are looking for the future. We work with very experienced people. It's a pleasure for me. I feel really blessed. So having work for this kind of people, very good experts in their field. They are kind, compassionate, and they really help to progress in a very good way. So I would like to express my heartfelt gratitude to Dr. Ruben Krizelt and also Carolyn Kemp for unwavering support in this project of a low protein. It's pretty much has been a rabbit hole, yeah. And but I think we like what we will discuss with you. So and besides them, so I'd like to really, we are really appreciative with Dr. James Lee, Dr. Roshan, Dr. Andreas Lim, and also Miguel Barrios and Dr. Jan Fontaine from GFO. Without them, definitely, we wouldn't achieve what we have found so far. So it's a beautiful collaborative work, and we are really, really proud of that. Yeah. So going to the rabbit hole. So I hope you enjoyed that. Yeah. So the current trend of a low protein diets definitely is driven by some factors that us as industry you should try to balance. So because when you talk about Europe, they have their priorities. You go to Asia, Oceania, or Latin America, they have others. So then I point out some aspects that are involved in low protein diets. Feed cost and food chain security. Then you see people really willing to reduce the reliance on soybean meal. Yeah. Then comes to sustainability, land usage. So that is all the questions on concerns about deforestation. Yeah, and I think the Brazilians, they are working on the certifications and trying to provide to the Europeans soybean meal that's not involved in areas with deforestation. There is also a big concern about the reduction of the emissions of nitrogen excretion. Yeah. Welfare, all related with PODO and leader quality. I have some pictures that I think you'll find interesting. And gut health. So soybean meal is a very good source of protein, but it's not perfect. No? Our piglets tell that, yeah? Is it true? So there is problems with buffer capacity, protein digestion, variability, etc., etc. So I will try to put all these things together and give you some perspective from our side. So we have some pressing questions every time I meet with all that 12 nutritionists, you know. So should we be able to replace 100% of a soybean meal? Go big or go home? This is the way, Antonio. Yeah. So how much can crude protein be reduced? Yeah. And what about the starter phase? We have people really obsessed with starter phase. Don't touch the starter phase. Don't touch the starter phase. Yeah. And the question is, what's the ideal amino acid profile in low protein practical diets? So we have available nowadays 8 synthetic amino acids or feed-grade amino acids or non-bound amino acids. Call whatever you want. Yeah. So it's pretty much arginine, valine, tryptophan, lysine, methionine. So all histidine, yeah, is available. But unfortunately, having all these amino acids gives us this false sense of fulfillment, you know. And many times in the formulations, what we see, nobody touched no essential amino acids. We still have, should I have a X or Y ratio for no essentials and essentials, things like that. So I've never used that. Dr. Fancher was really adamant in relation to proline, talking is a semi-essential amino acids for some phases. Yeah? And we called the neglected essential amino acids. Yeah, pretty much phenylalanine and tyrosine. Then you turn around the barrel, what you have is a broken profile. Yeah, so I think our journey in long protein is understand how to fix the different amino acids in order to comply with the whole requirement of our birds or piglets or pigs. So for sure, I left some good references behind, but just to give you a perspective about how we see or we are actually referred in terms of ideal amino acid profiles. We have Baker et al. 1994, Mack et al. And et al. 1999, Roth et al. 2011, Dr. Rostanio's tables, Wu from Texas A&M, Dorrigan from Dr. Sakamura's lab, that he used two very fancy methods, comparative slaughter and nitrogen retention. So, but my point here is that when you compare with starter diets based on corn or soybean meal, corn or wheat, sorry, the ratios are really close. Okay? No matter how we slice it, you'll not find more than 2 points FCR difference in the field. It does matter. Yeah. But, and you see that leucine continues to be a critical limiting amino acid because of the antagonism with valine and isoleucine. So we have formulations in Asia where ratio leucine to lysine goes to 200. Yeah, and nothing is added in terms of valine or isoleucine, as all the recent studies actually have shown. Yeah. Another point is related with phenylalanine and tyrosine. So we have references from 105 to 127. Yeah? And practical diets, they have 134, 140. Nobody cares about phenylalanine and tyrosine. Yeah? And when it comes with no essential amino acids, then we are on uncharted waters. Yeah, we have one reference with some very discrepant recommendations like glycine 176, glutamic really low compared with practical diets. So, and it's pretty much what we're dealing with when you go in this direction of a low protein. Yeah. So we don't have enough references, and we don't know how reliable they are. And nobody has tried. Yeah? So, and interesting when we compare corn-based diets and wheat-based diets, we have this kind of discrepancies in terms of, or difference in terms of amino acids, no essential amino acids. Alanine is lower in wheat-based diet. Yeah? Glutamic acid is lower in corn-based diet. And proline is much lower in corn-based diet. So, you know the functions about glycine, glutamic, alanine, the amination, transamination, collagen formation, yeah? And many times, depending on the type of diet you have, you may face some issues in the end. So, going through soybean meal replacement. So we had a trial, 4 diets, 1 sex, 8 replicates, was 308, it was actually carried out in Europe, and the intention was to work with a Brazilian soybean meal and soy oil from Brazil, and we replaced 50% of the soybean meal and oil and 100%. And we took advantage of this trial and say, okay, we have to reduce soybean meal. Let's see what happens if we add high levels of synthetic amino acids. But Bart mentioned that all the limitations they have with use of glycine is not approved. Yeah? And then one of the main strategies that has been applied by the group of Australian that Peter Crystal made part was the supplementation of a glycine and threonine, yeah, a higher supplementation. But what we did, we tried to reduce 3 points of 3 percentage points of accrued protein in wheat-based diets. Yeah, and the main raw materials: sunflower meal, rapeseed meal, and so on and so forth. So you see the distribution. In terms of protein reduction, we have around 3% protein reduction in low protein, 3.4 and 2.6. So it was a very expressive protein reduction, but we just supplemented the commercial available amino acids. Yeah, so this is the biggest limitation, but our intention here is to capture, okay, let's see what happened, yeah, and if this practice is feasible. So here is the comparison. You have 33 points. It's a European diet. You know that they are really crazy about lysine control. Yeah. So and compared with our starter diets, it's really low. 33.7, 16.9 in a starter with 50% replacement, and of course 0 soybean inclusion 100%. In the grower phase, 30% soybean meal with 50% replacement, 15%, and 0 in the 100% replacement, and so on and so forth for the finisher phase. But then we start building up what happened in terms of other alternative ingredients. You see, we used sunflower meal, high pro, canola meal, peas, corn gluten, and the potato protein. So very complex. And we have the same questions, Bart, when you see the results. So why actually performed well or didn't perform well? Yeah. Anyway, here is the different colors, very interesting. You know, the more alternative ingredients, the darker the feed, and the low crude protein feed, very pale, yellow, yeah, yellow. Yeah, and the interesting thing is this observation, yeah? So the leader color changed in the opposed direction. So we got a pale color using alternative ingredients compared with soybean meal use. And Jason just said, Marcelo, why the leader changed the color to the, I'm not a leader expert, so I don't know, it probably it's fermentation or something else, you know. It's something that definitely is undigested, fermented, and changed in the soybean meal feed. But going to the performance, what we see, it's really nice, yeah? So 50% replacement, take into account the variability of the alternative ingredients, but all formulated in digestible amino acid base. So it's expected to achieve the same performance, yeah? And definitely we got there. And even the low protein diet, we got good results, yeah? And feed conversion suffer, that is a scaling problem, yeah? But you see, you have a 1.5 points difference in terms of feed conversion. So far, the practice is really good. So you can replace soybean meal, you can reduce protein without any problem, yeah? But what about the meat yield? And this is one of our criticisms in low protein strategies. Many times, they just stop the evaluation at live performance and forget the processing traits, yeah? And has been a trend in our trials that low protein diets really results in less carcass yield and less low protein, yeah? And you compare with bar the data, you see our control diet, we got 26% rest yield. So how much amino acid actually could go or put over your formulation to get more yield? So are you actually really take advantage of the genetic potential to maximize meat yield? So this is another question. So your baseline has to be very well established in order to provide a very fair comparison. So our biggest concern was why low protein diets actually have resulted in low meat yield. Yeah? And we tried to pursue these responses. So, and it's very interesting that phage-feed protein reduction in cereal type has been actually being discussed, yeah, and Peter Christos in our group, and the thing is discussed that the protein reduction after the starter phase, yeah, should we actually avoid the protein reduction in the starter phase? Yeah, how the bird would respond when we use low protein. Crystal really says that corn-based diets are more conducive, yeah, to low protein diets. And our aim here was to investigate the effect of protein reduction in different phases in cereal sources. So the first trial we reduced all again since the starter phase. It was the worst result. So, and that we jump to the second trial that we combine corn and soybean meal in 100% or 50-50. And we reduce 2 points from the grower phase on, or 3 points. So then you have here the summary. You can see CCC is the control diet. CMLL is 2% reduction in the grower phase and 3% at 3% point reduction in the finisher 1 and finisher 2. We also followed one of the strategies related to increments in the threonine, valine, and arginine to 72, 82, and 112. We missed glycine because of the limitations of using glycine and actually handle the birds afterwards. And then you have these treatments and just an intermediate reduction to 2% reduction in the grower, in the finisher 1, and in the finisher 2. In wheat diets, wheat-corn diets, 50-50, and corn diets. Interesting results. You can see there is a significant effect at 0.06 for cereal, and a highly significant effect for the protein strategy. Interesting enough is that performance was a little better numerically, yeah, when you compare the cereals. And as we reduced the protein reduction, or we didn't go that far to 3%, you see an improvement in performance. Interesting that when we supplemented threonine, valine, and arginine to 72, 82, 112, we didn't get any good results on that. And there is some differences in terms of body weight. FCR, we see the same trend. Yeah, cereals were really significant, protein significant, and you see the difference in FCR of wheat diet and wheat corn diet versus corn. So corn was the best result. And again, FCR didn't change much with the best result with the control. So we were not able to catch up with the positive control properly. Yeah. And the breast meat yield, again, we repeated it. So compared with the control, the breast meat yield was much lower with any of the strategies we adopted to reduce protein. And feel free to take pictures, no problem. So our preliminary outcomes, lower dietary protein resulted in poor performance and lower meat yield, okay? Possible reasons, insufficient neglect limiting amino acids. Then we point out histidine and phenylalanine tyrosine. Specific amino acids, then we have the whole list: lysine, serine, proline, aspartic, glutamic, alanine. Yeah. We also discussed the inefficient transsulfuration pathway given that you need enough serine to convert methionine into cysteine, yeah, and we reduce protein. Serine is one of the amino acids we reduce. Or all the questions related with intact protein versus no-bound amino acids. So going deeper in the rabbit hole, so we tested the effect of phenylalanine and tyrosine and histidine in low-protein diets. We had, again, the positive control, supplemented with L-methionine, L-leucine, L-threonine, L-valine, L-isoleucine, arginine, and tryptophan. Negative control, 3 percentage points lower in crude protein. We added 4.3% of a cornstarch. Corn-based diets, I mentioned that. Negative control, 3 percentage points lower in crude protein. Digestible histidine and phenylalanine adjusted to 38 and 114. Remember that there is a big range in terms of recommendations, 105, 127. We were in the middle. And we had to add histidine, HCl, and L-phenylalanine. So we used the rostral 8AP males. This trial was carried out in Albertville, our research farm in Alabama. Corn, soybean-based diets, 18 birds per pen. We took out 3 birds at 25 days for just in case do digestibility trials, yeah, and we have a 4-feeding phase program. And we found a very interesting result where phenylalanine and tyrosine supplementation and histidine helped us to recover partially the growth rate, the FCR, and impressively recovering carcass yield and the breast meat yield. Yeah, it was a big watch out for us. Yeah, and I give all the credits to Jason Lee, because he was the one telling us you should try complete the ideal amino acid profile in terms of essentials. Yeah, and definitely was something remarkable. And we followed from that point on. Our thoughts about serine and inefficient transsulfuration pathway went well up to 35 days. One thing that we don't understand, why when you supplement cysteine as actual cysteine requirement, we didn't find good results in performance in terms of live weight and feed conversion. Yeah, and the serine was really good. Was a really good strategy over phenylalanine and histidine up to 35 days. That tells us that serine has an important role early on, and maybe because of the feather development and the changing down feathers for adult feathers, and a lot of cysteine is required. Yeah. Anyway, we'll discuss serine in the next trial as well. So then we have so far that if you don't have no essential amino acids or limited in terms of strategies like glycine, definitely we don't use protein reduction in the starter phase, and maybe we could reduce up to 2 percentage points of crude protein. That's pretty much aligned with your finds, Bart. But we have serine in the other amino acids, and all the discussion related with intact protein and bound no essential amino acids. Then it's pretty much what we've done. You have 3 groups here. So the first group is the positive control. The second group, negative control, taking into account phenylalanine, tyrosine, and histidine. Yeah. And the blue bars, we try to reconstitute the protein reduction in 1, 2, and 3 points, adding collagen. that we considered as intact protein and very digestible protein. In the orange bars, we did what we called copycat. So it's mimicked no essential amino acid profile based on the collagen profile. But we used all the non-synthetic glycine, alanine, glutamic, aspartic, all the complete list as is. And interesting enough is that was the strategy that gave us the best performance, and we were able to catch up with the FCR. Yeah, very, very interesting results. And for us was a bit surprised why collagen 1 and 2 didn't result in comparable results. Yeah, and for us is that probably we overestimated digestibility. Yeah, and really impacted negatively in the performance. In terms of processing traits, it was really interesting to see that just bumping up histidine and phenylalanine, we are able to recover 100% the carcass yield, but not totally the breast meat yield. Of course, statistically, it's not 100% different, but we process 100% of the bird. So we could do a different analysis and get the significance we needed. But interesting is that collagen, again, didn't result in the best breast meat yield, but supplementing all the non-essentials mimicking the collagen really help to catch up with the breast meat yield. Yeah. But then we had, again, the unanswered questions. So which non-essential amino acids are necessary in a low-protein diet to maintain performance and meat yield of broilers? Were the responses misled by corn-based diets? So the first trial was wheat diet. The second the second trial, corn-based diets. And someone asked me, what about corn wheat-based diets? Let's go in this direction, yeah? So because it's pretty much how the world will work. So, and if they want to go for a very efficient strategy, yeah? So, and the last question is that would an increased level of phenylalanine and tyrosine and histidine improve performance and meat yield even more? So how far could we go? Yeah, then we designed the third trial, evaluated the influence of non-bound, non-essential amino acids, phenylalanine, tyrosine, and histidine in reduced protein broiler diets. So we had, again, the positive control, all available commercial feed grades, supplementary amino acids, but histidine. Yeah. 3 percentage points reduction in crude protein for the negative control. And you see the design we called -1. Histidine was set to 38, phenylalanine tyrosine 114. And given we were using wheat-based diets, wheat in the diet, so we increased glutamic to 250, 260, and 270 in the starter, grower, and finisher feeds. The previous trial, glutamic, was around 230. It is the biggest difference that we got in the corn-based diets. And you had the +1, where we adopted all the synthetic amino acids 10% above, equivalent to the profile of 1.5% of collagen. So, but all in non-bound form. Very well. Then we were brave enough to play with Plack-Berman, 1946, 8 factors, 2 levels, serine, glycine, glutamic, aspartic acid, alanine, prolamine, histidine, phenylalanine, tyrosine in 2 levels. So the negative control and 10% additional amino acids that was close to 1.5% collagen. 12 runs, one treatment with all high level of amino acids, non-synthetic, non-essential amino acids. The positive control 8 replicates, as I mentioned, with corn-based diets. We used ROS 344, 308 AP in a 4-stage feeding program. Here is the design. You have the code matrix here that you can see. And in blue, you have the highest level, the +1. And in yellow, you have the lowest level, -1. And in each run, you have the amino acids that were increased or decreased properly. Interesting thing is how the diets were designed. You can see that the negative control, or -1 and the +1, they had the same amount of soybean meal, 26% against 32%. Sorry, is 38% in the soybean meal, 21% against 32% in the positive control in the grower phase, 18% against 30% in the finisher phase, and the withdrawal 15% against 27%. It's a very significant reduction in terms of soybean meal. But the strategy was not reduce soybean meal, it's to test the non-essential amino acids. And when we talk about the non-bound amino acids and intact protein, you can see that we added 21, 20, 19.6, and almost 20 kilos of non-essential amino acids per ton, for metric ton. And additionally of another 20 kilos of the essential amino acids. So we're talking about 40 kilos of total non-synthetic amino acids. And you see the results is in line what Bart mentioned to us, that we are far away of the highest level of inclusion of non-essential amino acids. Of course, Dr. Gauss has all the trials related with breeders that make a lot of sense, a lower utilization, because birds are fed just once, and it seems that the broilers don't follow the same pattern. So in terms of live body weight, it's really interesting to see again that we were able to achieve the same level of a body weight with the negative control. But adding the different combinations of amino acids, we got that the glutamic acid and glycine played the major role in terms of improvement in relation to the negative and positive control. And amazingly was what we found with the increasing all the amino acids in 10% in relation to the negative control. So we got the best performance in terms of body weight. That tells us that in the practical diet, we are not there in terms of ideal amino acid profile in the non-essential part. So just increasing glutamic and glycine, we would increase 100 grams in body weight gain. So there are a lot of room for improvements in our practical diets. Interesting, you see that proline is much less significant. But as I mentioned, proline may be, if you analyze the data from the starter phase or the grower phase, we see proline playing a very important role that fades away later on. So we could consider specific requirements for proline in the starter and the grower phase. For FCR, we lost a little bit of FCR here with negative control that definitely could be adjusted by including or increasing glycine and serine ratios. So each of the amino acids that were treated complete separately, resulted in 1 point FCR improvement. So if you increase glycine, if you increase proline, definitely will be able to recover FCR and improving also the body weight at 41 days. Carcassonne, again, just including phenylalanine, histidine, and glutamic acid at 20, 50, 26, 27. we got a better carcass yield. Yeah. All the other treatments worked really fine, but the most interesting finding here was the effect of histidine. Yeah. Then aspartic, and aspartic being negative, and glycine again being positive, but just impacting 0.1% carcass yield. And you see that histidine really increasing almost 0.5% in terms of a carcass yield. That is aligned with all the finds that we see during this week during the symposium presentations. Breast meat, again, negative control, was not able to provide the same level of a breast meat, but again, histidine and glycine played a very important role, okay? And amazingly was when we supplemented all the amino acids, we got almost 0.5 point, 0.6 point in breast meat yield. And when we combine the treatment 8, you see that you have a glutamic, proline, glycine, histidine. And I would disregard phenylalanine because phenylalanine had a negative impact. No, increased a little bit, but not significant. You see the treatment 8 gave us 29% breast yield. It's huge. So it's a very interesting opportunity for future evaluations. Yeah. And leg quarters was pretty much the same. Histidine and phenylalanine, proline with significant effects, but the only one positive was related with histidine. So histidine playing an important role in terms of breast meat yield. Here is the most intriguing part. So why, when we reduce protein, we increase carcass fat? It's negligible, 0.2 for the modern bird, but means for us that when you add no essential amino acids and reduce soybean meal, what happens is that the bird needs less energy for deamination or transamination or something. So then we should try also to adjust the energy in order to achieve the same carcass composition. And I made some calculations with Dr. Diego Martinez, and you see the effect of a 0.1% of abdominal fat in the energy in the feed. So, well, I'm daring a little bit here, yeah, and we came up with what would be the ideal amino acid profile in low protein diets. Sorry, and definitely we should keep histidine close to 38, phenylalanine 114, alanine 55, 56, 57, 58, aspartic from 115 reducing to 105. Definitely, we think that glutamic acid played a very important role, and we should keep at least 250 going up naturally with increasing the cereals. Yeah. Glycine and serine around 130, 140, and the proline at 90. And definitely, we don't mind to be mistaken here, provided that you guys try the right path to be right. I think it's a very good reference, yeah? And I think this is the challenge that we'll have to fight together, yeah? And see, because it's pretty much the limits and where are the boundaries? And the more than that, we could enhance performance with even higher profiles. Glutamic going to 280, glycine and serine to 145, and proline 105. With the current synthetic amino acids price, of course, is completely unacceptable. But one of the questions is, could we adopted something closer in practical diets. So going in the opposite direction. Yeah. And I didn't touch nitrogen utilization here because it's clear that when you reduce protein, you improve the utilization. But it's a balance. Yeah. How much will you give up in terms of breast meat? Yeah. In order to comply with nitrogen retention or utilization, polydermatites, or things like that. So the discussion, our discussion is our global discussion. And we have the specific discussions with face-to-face with customers of each region in order to set the best strategies. So, main finds summary. So, low protein diets without no essential amino acid supplementation. You can reduce 2 or 3 points after the starter diet. It seems that control 2% reduction and 3% reduction could be more approachable. We know that corn diets give us better results compared with corn wheat and wheat. So definitely we have to go in the direction of corn. Yeah. We still had losses in terms of meat yield, poor FCR. Low protein diets require minimum of phenylalanine, histidine, and glutamic. Is 114, is 38, is 250. Maybe a little bit lower, maybe a little bit higher. It's something that we have to dare ourselves to find out. Yeah. Some amino acids presented better response early stage, proline and serine. So that might require optimization by phase. I count on you guys to start working on that. Supplementation of non-essential amino acids allows enhanced light performance and processing traits when compared with practical diets. This is fabulous. Okay. And one of the questions is, should this be resulted of soybean meal reduction? Because definitely we set a much better stage for the birds with lower soybean meal content. Yeah. Despite negligible differences, high abdominal fat in low protein diets is likely result of an energy sparing effect, deamination, transamination, or nitrogen excretion. And then I made another question. Is there enough room for energy reduction in balanced low protein diets? So based on the calculations I did with Dr. Martinez, every 0.1% of abdominal fat reduction might correspond to energy reduction 10 kilocalories per pound or 22.5 kilocalories per kilo. It's a lot of money. Okay, so would help us to balance our diets much better. And again, so our challenge is to study better this amino acid, no essential amino acid profile, and see how far we can go on that. So thank you very much. I really appreciate the opportunity.